Hello and welcome to another fun-filled adventure in math with Mr. Sims. Today we're going to be studying for our test that you're going to be taking this week. So the test is test 114, I believe is the one we're on. And this is the cycle 19 test, so make sure you're all buckled up and ready to go. We're going to jump right in. Once again, I'm going to do as many problems as I can in about 30 minutes. So yeah, get your paper handy so that you can turn it in and get the 10 points, the 10 free bonus points. Once again, I hope you're having a wonderful day. Let's go ahead and get started. Alexa, set a timer for 30 minutes. Alright, so the first one says solve using the quadratic formula. So when you're looking at doing the quadratic formula, what you're looking at is x, whoops, let me try and make it a little bit smaller. Let's try this. Yes, x is equal to negative b plus or minus the square root of b squared minus 4 times my a times my c. I'm sorry in advance, I'm having some issues with I had my computer died on me, so what I'm trying to do is I'm trying to get all the softwares up and all the settings back to where they should be. So just so you know, it's going to be a little bit of a trial run today. We're going to see what's happening with this stuff. So hopefully I can get better as we go. So anyway, here we go. So x is equal to negative b plus or minus the square root of b squared minus 4ac, and that's all over 2a, okay? So when you're looking at this, what we need to recognize is that with the quadratic formula, by the way, is the easiest way for you to factor a problem for most problems, okay? So the way, or at least to get the zeros. So the way you're going to do it is this. You have your a is equal to, as I can see, the a is equal to 2, the b is equal to negative 3, and the c is equal to negative 5, all right? So what I have is I have x is equal to negative b, so I'm just going to start filling these things in. So I have a negative, my b is negative 3, so I have negative 3 plus or minus the square root of b squared, which is going to be, once again, negative 3 squared minus 4 times my a, which is, my a is what, 2, times my c. My c is going to be negative 5. All right. And that's all over, whoa, that did not work. Let me try this again. All over 2 times my a, which is 2. All right. So what I have here now is I've plugged in everything that I had, right? And what I need to do is I need to come over here and figure out negative times a negative 3. I'm just going to simplify a few things. So this is going to be positive 3 on this side, plus or minus the square root of, and really all of this here, this is called the discriminant. All of this I can do as one whole chunk in my calculator, and I do suggest that you do that. I don't suggest you try and do this whole thing here in your calculator. If you try and do the whole entire equation in your calculator, a lot of people mess up the plus and minuses, and they don't get the parentheses in the right place and things like that. So my suggestion, once again, is you do it piecemeal like I'm doing right now. So, oh, I think I might be running out of batteries here too. So I have negative 3 squared minus 4 times 2 times negative 5. All right, so when I type that in, I get 49. So what that's telling me is that this is the square root of 49, and that's all over, whoa, didn't want to do that. That's all over 4. Okay, so at this point I have 3 plus or minus 49. Now if this can simplify, then you want to simplify it and make two equations out of it. If it doesn't, you would just leave it right here. But because the square root of 49 does in fact simplify, I'm going to go over here. I'm going to get 3 plus or minus the square root of 49 is 7 all over 4. So what I have here now is I'm going to make two equations here. I'm going to make one equation that's 3 plus 7 over 4. I'm going to make the other one 3 minus 7 over 4. And this 3 plus 7 is really going to be 10 over 4, right? This 3 minus 7 is going to be negative 4 over 4. So 10 over 4 simplifies to 5 halves. Negative 4 over 4 simplifies to negative 1, right? So I have one answer where x is equal to 5 halves, and the other one where x is equal to -1. Now you might be wondering, what does that actually mean? What does it represent? It means that if I were to graph this quadratic function, right? Let's say the quadratic function looked like this, right? The two zeros, when I graph them, one zero would be at -1. Let's say this was -1 here. So that'd be 1, 0, right? And the other zero would be over, actually the other zero would be over here somewhere at 5 halves, which would be over here somewhere. So basically my parabola would look essentially like this, not like this one here. Okay, so that's what your parabola would look like at -1 and 5. This would be 5 halves, all right? Once again, I'm sorry about the writing. It should get better as I do these again. Once again, my computer just died, so I'm in the process of getting everything fixed. Here we go. Which step is incorrect? Let's look at this one now. Which step is incorrect? So I have an example of what they're doing is a quadratic formula, and you'll notice that this is really an important formula. You'll want to commit this to memory. I don't say that about a lot of formulas, but this one is definitely one that you want to do that. Okay, once again, a is going to be 9, and they want to know which step is incorrect. So one of the ways you can do it is you basically just run through the problem, and then see where it doesn't match up with yours. So c is equal, sorry, this is c. c is equal to -4, okay? One thing, because this is my A, my B, and my C. So I have -7 plus or minus the square root of B squared minus 4AC. So let's check this out real quick and see if they put it in right. So x is equal to, once again, -b plus or minus the square root of B squared minus 4AC all over, try that again, all over 2a. So I'm looking for -b. I'm looking for a negative times a -7. And right here, I can automatically see that they messed up, because this was a -7, and this should be -b. So it should have been negative times a -b, but they just had the b there by itself. So right there is my mistake, right there. They also, let's see, did they make a mistake here? No, they got that one right. So it's just this first one here. They should have made it a negative times a -7, but they didn't. So that was the problem. It was in step 1. Okay, good job. Yay! Okay, so step 1 is the answer for that one. All right, let's go ahead and keep going. A savings account is opened with an initial deposit. Interest is paid on the account balance and is compounded annually. The account balance, A after n years, is given by this formula. So all of this was just kind of a prelude to that, or basically a background to that, right? What does M represent in this situation? So I have A is equal to, once again, oh, I don't need to rewrite it, it's there. So here's my formula. So A is the account amount that's going to be in the balance, right? Now, whenever you have something raised to a power, like in an exponential thing, the thing that's raised to a power is your growth rate. So it looks like my growth rate here is 1.05. All right, that's my growth rate. And what that means is that every year it's accruing 5% interest. It has the whole value of the account, which is the 100%, plus the 5%. All right, now that's not what we need to know, but I just wanted you to know that's the growth rate. The n is the amount of time that we're looking at, right? The time, right? And the m is always going to be the thing that's multiplied times that growth rate raised to the power is going to be your starting amount. So this is your initial amount or your starting amount. So in this case here, it would be the amount of the initial deposit, because he's opening the amount with an initial deposit. And interest is paid on that annually. But anyway, this is the amount that we're looking for. The interest rate, by the way, would be this 1.05, right? The amount of time in n years would be the time here, n, and the maximum account balance possible. There is no maximum account. This is going to grow on forever. It's actually going to get very big over time very quickly later on. So anyway, gives you the basic idea. Let's go ahead and move on. Yay! So the graph of the function g was obtained from the graph of the function f using a transformation as shown below. All right, so it's saying that G came from F. This is always important to realize that, right? So G came from F. Usually it follows the letter of the alphabet F, G, H, J, right? So G would come from F because F came before it, right? That's how it normally goes, right? Which best represents this transformation? So if I look at F, it's looking like the vertex is staying in the same place. That's important to recognize because that means it's not going up, it's not going down, it's not going left, or it's not going right, because then the vertex would actually move. What this is happening is this is what we call a stretch. This is either a horizontal stretch where the whole thing is getting stretched upwards, or it could be a vertical stretch or a horizontal compression. It could be being pushed this way as well, right? But in this case, let's go ahead and start and assume it's a horizontal compression and see where it's moving. It's moving from that point to there. You always want to look for x is 1. So when x is 1, the y value of the f is 1. The y value of the g is 3. So it's going from 1 to 3. Well, the question is, what do we multiply by? Because we know it's a stretch or a compression of some sort, we want to know what do we multiply by to get 3. Well, you would multiply 1 times 3 to get 3. So what's happening is it's increasing by a scale factor of 3. So if something's increasing by a scale factor of 3, then it's going to be 3 multiplied by the f of x. That's how I get that scale factor of 3. So this is the answer here. This one here, what would happen is the actual graph would be much shallower, and it would cross at 1/2, right? This would be a compression, vertical compression by a scale factor of 1/2. This one here would be you'd be moving the whole thing up by 3, right? So it looks something like that maybe, right? Where the whole thing moves up by 3. And this one here, -3, would be moving the whole thing to the right by 3. Remember, if it's inside with the x, it always does the opposite of what you think. You would have thought it would go this way, but actually it's going this way by 3, okay? So once again, the correct answer is 3 because this is the only one that's stretching it aside from this one, which would be actually compressing it. All right, moving on. Which graph can be obtained by translating the graph of this down 9 units? There's actually 2 ways you could do this. They're both kind of fun. So this one here, what I would do, first of all, option number 1, I could take and I could graph this in my calculator. If I graph this in my calculator, it's going to have a vertex. And then I would move that vertex down 9 and see which graph matches it. All right? So that's option number 1. Option number 2, I think, is a little bit more fun because what we have is we have g of x basically being h of x. Let's not do g of x then. hij. Let's do j of x, okay? So j of x then, I'm going to say j of x is going to be h of x, right? And if they want to move down 9 units, I'm going to take that h of x, I'm going to minus 9, okay? So what I'm going to do is I'm going to take this 0.33 x squared plus 2, and I'm just going to minus 9 at the end, okay? Just like I said, take the h of x, which was this, right, and minus 9. So now what I have is I have 0.33 x squared minus 7. And I can take this right here, and I can actually plug this straight into my calculator. And I can actually graph it and see what it looks like. But there's another way I could do this now that I have this. So if you didn't graph this in your calculator right now, I do suggest that's probably the easiest way to do this, right? So if you didn't do that, what you could realize is that, hey, when x is 0, right, all of this goes away, and what's left is -7, which means that -7 is my y-intercept, because when x is 0, I'm on the y-axis, right? So my y-intercept in this case is going to be -7, which is right here, right? Having a little bit issues here. There we go. All right, so hopefully that's making a lot of sense to you. But yeah, that's the -7 that we're looking at right there. So this one here would have a y-intercept -5. This one would have +7 and +9. So once again, this D is the correct answer because of that. All right. But anyway, yeah, like I said, probably the easiest way to do this is graph it the first time in your calculator. Then just move that vertex down 9 and see where you end up, right? That's option 1. The second option is to do what I did and then graph this in your calculator and see which one matches, right? So both of those work. Yeah, moving on. Get your math geek on. Here we go. What's the asymptote of the exponential graph to the right. So the asymptote is the place. Remember, I like to describe it like a stunt car driver. This stunt car driver, he's driving here, and he wants to make it so interesting, right? So he's going to veer. He's going to turn right at the last minute. You see he's kind of turning right at the last minute. And notice he's going to try and follow this wall and get as close as he can to this wall without touching it, right? That makes it an exciting car driving scene, right? So in this case here, that wall that we're talking about is what's called the asymptote, and you never, ever, ever touch the asymptote. So here I have -4. This line is on -4, right? It's crossing the y-axis, so that tells me it's going to be y equals -4, and that right there is the asymptote, okay? Now I do have to let you know, this up here is not an asymptote. It looks different. You can see how this one he veers sharply. This one kind of keeps going. The slope keeps going, right? And that one's going to keep going on forever. Now, just so you know, you can have any x value all the way to infinity or negative infinity. But that's not important for this problem. This problem, they just want to know the asymptote. The asymptote is a. Bada bing, bada boom. Here we go. Let's go. What is the domain of the exponential graph below? So the domain of the exponential graph below is, oh, yeah. So the domain's asking for, whenever you see domain, you should think x, because that's the x values. So it's saying, hey, what can all the possible x values be? Well, guess what? You can have any x values all the way to positive infinity or all the way to negative infinity. Now, if you do go like even -1000, it's going to be a huge, massive number because it's going to go very high. That's what the exponential is going to do. But technically, there is a value. It's just a massive value that's going to be at negative infinity. So the answer is you can have any x values at all, any x values, all the decimals and everything. So that's going to include all real numbers. This one here, it looks like it could work, but it's only the ones on the graph here. It's only going from -3 to 3. It's assuming there's nothing else outside of this, and that's not real, right? So this one's out. This one's x is greater than -3. If x is going to be greater than -3, that means it would only be able to be x values past this, which means this line wouldn't even exist, right? So that's out. And this one's saying the domain is only from -3 to 3. And that's also out because it's an exponential graph and it's going to go on forever. I don't like that they did not put their arrows. That kind of bothers me a little bit, just so you know. But hopefully yours will have arrows. The arrows kind of help tip you off that it does go on forever. Okay, but it is an exponential, so it will. All right, let's keep going. Ding, 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 ding. What is the range of the exponential graph below? Let me zoom in just a little bit more, just because it's fun. What is the range of the exponential graph below? Oh boy. Oh yeah, range. So range is all the possible y values, right? So it looks like my y values basically go from here to, well, it looks like on and on and on to infinity and beyond. So my y values are going to be from -4 or basically higher, anything above -4, right? So those are my possible y values. So if I look at this here, all real numbers would include all the numbers past -4 here. And that actually doesn't work here because you can see there's an asymptote right here. So it's never going to go below this -4. So 0 to 6, 0 to 6 would only be from here to there. That doesn't even make sense. So y values greater than -4. Well, that's looking promising. It looks like my y values do go anything greater than -4, right? Anything there and above. So that actually looks like a possibility. Let's go ahead and do, let's go ahead and look at one more. I think that's the right answer, but let's go look at one more. This one says -6, which is right here, to 3, which would only be like right here. And that doesn't make sense. Your y values don't go just from there to there, right? As you can see, there's y values here and here and here and here and here and here and here. So all of those y values would also be values. So that does not make any sense at all. The correct answer is C. All right, zoom, zoom, zoom. All right, an adult takes 600 milligrams of ibuprofen. Each hour, the amount of ibuprofen in a person's system decreases by 35%. How much ibuprofen is left after 7 hours? By the way, this is, you guys are always asking about real life scenarios, right, for algebra, and these are real life scenarios for algebra. Exponentials come in handy all the time, right? So here we go. An adult takes 600 milligrams of ibuprofen. Each hour, the amount in the person's system decreases by 35. How much ibuprofen is left after 7 hours? So we'll start off with the initial amount. My initial amount is 600 milligrams. The sorry, the the decay percent. This is decay, right? It's getting smaller, right? So the decay percentage is going to be 35%, right? 35% is how much it decays each time, right? So if I want to figure out the rate, of decay, right? The rate of decay then is going to be the initial amount I start with, which is a total 100%. And from that 100%, I'm going to take away 35%. Okay, and so that's going to give me 100 minus 35, which is 65. So 65% is my decay rate, all right? So this is once again, my decay rate, my rate of decay. Now I want to turn that into a decimal. So the way you turn these into decimals, you start here where the decimal is at, because it's at the end, right? And I'm going to move it 2 to the left. So it's going to be 0.65. So my decay rate expressed as a decimal is 0.65 or 0.65, you might see. Okay, so in this case here, it looks like I have most of the things. In fact, I have all the things I need. So I'm going to start with the basic formula for the basic form for an exponential. That's y is equal to a times b to the x, right? And actually, I like to write mine with the b in parentheses. That's just me. So b to the x power. And remember, the thing that's raised to the x power is your decay rate, right? So it's going to be, well, actually, let me start with A. A is going to be your initial amount, right? Which is going to be 600. So I have my 600, and that's multiplied by the thing that's raised to the x power. So the thing raised to the x power is going to be 0.65, which is our decay rate, raised to the x power. And now if I calculate that out, I just put this all in my calculator here, I should get, oh, and my x, this is the function that would be it, right? But they're not actually asking for the function. What do they want? They want to know how much is left after 7 hours. So they want to know after 7 hours, right? So I'm going to take my 600 times 0.65, and I'm going to raise that to the x value is going to be 7. Because each hour, right? Each hour, the amount decreases, right? By that amount. So that gives me, if I calculate it out, let me calculate it out real quick. I have 600. Try that again. 600 times 0.65 to the, that was not the right button, 0.65 to the 7 power. And I get 29.41336, some really ugly number over here. And they say to round it to the, oh, they don't say to round it to the 10th. So that's what we're going to do though. We're going to round it to the 10th here. I'm going to say it's about 29.41. I look to the right. This one's not higher than 5 or 5 even. So this is going to stay a 1. So 29.41 is my milligrams of ibuprofen in a person's system. All right. So, okay, how we doing? If they don't say, I think a lot of times it's safe to round it to like the 10th place, okay? Especially with money, you always want to round it to the 10th place because that's where pennies are at, right? All right, let's keep going. Which of the following describes all the solutions to the inequality? Oh, by the way, there's another way you could have done this one. Let me go ahead and show you that real quick. You could have also done, remember, sometimes B is split up into 1 minus R, right? 1 minus R to the X. And so you really could have done it like this too, where you had Y is equal to, you start off with your 600 times 1 minus the 35, right? 0.35. We're going to make 0.35 this time as a decimal. So this is another way you could do it, right? The only difference is all of this here that we did here, and then we converted it to a decimal, is all just starts off at a decimal and is done right there, okay? So don't be too confused by that. That's actually how that would how that plays out. Okay, so let's go ahead and keep going now. Which of the following describes all the solutions to the inequality? So they say when y is equal to -6. So I'm going to start where y equals -6. I have, well, let me start by this. I have 5x plus 7y is greater than or equal to 23. And what I'm going to do is I'm going to take that 5x, I'm going to leave it, but they want to know when y is equal to -6. So I'm actually going to plug in -6 for y. Now when I plug in -6 for y, I get 5x plus 7 times -6 is greater than or equal to -23. Let me try that again. Greater than or equal to 23. So that's going to give me 5x minus 42, because 6 times 7 is 42, -6 times 7 is -42, is greater than or equal to 23. Now I'm going to add 42 to both sides. As you can see, all they did was they solved for x, right? So I get 5x is greater than or equal to 65. I divide by 5, I divide by 5, and I'm lucky I'm not dividing by negative. I don't have to flip anything. I just get x is greater than or equal to, what's that going to be, 13? Yeah, that's right. Yes. So x is greater than or equal to 13, which is which answer choice? C. Awesome. All right, I hope you guys are having a great time here. Let's keep going. I still got a little bit of time. Alexa, how much time is left on my timer?
You have 2 minutes and 50 seconds left on your 30-minute timer.
Awesome. All right, let's go ahead and try and knock. Maybe I can even knock 2 of these out. So this one's solved by factoring. So once again, this is a basic factoring equation. You should definitely know how to do factoring by now. If you don't know how to do basic factoring of trinomials, then what you need to do is get onto Math for Gremlins and find the video that's titled Factoring Trinomials. If you do that video and you actually work through the problems as many times as you need to, you will be a master at factoring trinomials. If you're not good at it and you're not doing that, then there's a problem. You need to be on that like white on right side paper plate in a snowstorm, okay? So make sure that you get on that, all right? So you have 7a squared plus 32 is equal to 7 minus 40a. I'm going to start by subtracting 7 from both sides. I have 7a squared. 32 minus 7 is going to be plus 25, right? Is equal to negative 40a, right? And you might be wondering why I'm doing this. Well, the problem is we have stuff on both sides of the equation. We can't have that. We need to get everything over to the other side, so I have my ax squared plus my bx plus c, right? So now my step is to add 40a to both sides. Add 40a. Once again, I'm sorry about the penmanship. The computer is not my friend until I get everything figured out. So 40a plus 25 is equal to 0. Now that we have 0 on this side and all of this on the left-hand side, what I can do is I can factor. So let's start with our x method, right? And I'm looking for two numbers that multiply to give me a times c and b. Okay, two numbers that multiply to give me 7 times 25. 7 times 25 is going to be 175. Right? And it has to add to give me 40. So I'm just going to go down here. I'm going to make my factors of 175. So my factors of 175 are 1 times 175. 2 doesn't work. 3, let's see, 8. 3 also doesn't work, actually. So here, let me just do these in the calculator. It'll be easier. 175 divided by 3 doesn't work. Sorry, 175 divided by 3 doesn't work. 175 divided by 4 doesn't work. 175 divided by 5 does work. We have 5 and 35, and actually that looks like it's going to work for me, because 5 times 35 gives me 175. Alexa, stop the timer. So 5 times 35 gives me the 175 that I'm looking for, and if I add 5 plus 35, I get 40. So that's the one I need. I need 5 and I need 35. So now I'm just going to go over here. I get 5. I get 35, right? And when I do that, I get Sorry, just testing something out. All right, so when I do that, I bring the 7a squared down, right? I just brought it down there. I bring the 5 down, and it's going to be 5 plus 5a. Once again, the whole point of doing all of this here on the right here was just so that we could get this 40a split up into the two terms that's going to factor nicely for us, right? So plus 35a, this is 35a here. And then finally, we have our 25, this is going to go right here, plus 25. So I have 7a squared plus 5a plus 35a plus 25. And I'm going to go ahead and I'm going to go ahead and factor out now. The biggest thing I can factor out of both of these is just a, so I'm going to divide both of these by a. So I get a on the outside times 7a plus 5. And over here, I want to get 7a plus 5 again so that I can do my cool magic trick. The way I'm going to do it is I'm going to divide by 5 and divide by 5, right? So I pull out that 5 now, and I get 7a plus 5 again. All right, so now these outside terms, the a and the plus 5, join together to become one factor, and the inside terms join together to become my other factor, right? 7a plus 5. And that's all equal to 0. Now they want us to solve it, so they actually want us to get the answers, not just the factors. So what I have to do is I have to set a plus 5 equal to 0, right? Because if multiplying these together gives me 0, then either one of them is 0 or both of them is 0, right? So 7a plus 5 is equal to 0. So this one here, I'm going to subtract 5 and subtract 5. And I get a is equal to negative 5. This one here, I'm going to subtract 5, and I get 7a is equal to negative 5. Divide by 7, divide by 7. I get a is equal to negative 5 sevenths. Now, the only thing I have to do now is put them in order from least to greatest. That's going to be negative 5, followed by negative 5 over 7. And that's my answer. All right, guys, it's looking like time is up, so I'm going to go ahead and end it there today. I really hope that made a lot of sense. Once again, review all these characteristics of quadratic formulas and exponentials. Make sure you understand how to do them, because the thing is, they're actually not that bad. You just need to figure out the processes and learn the processes. If you do those and you learn them well, you should get those right like every time, right? Now this one here, don't forget to learn your quadratic formula, and watch out for this double negative. That is what gets kids. Do not try and put all of this in your calculator at once. I'm going to tell you, if you do that, you will be sunk, right? So do it piece by piece like I did here. I did this piece, right? Then I did this piece, then I did this piece, and then once I got here, I simplified it, and then I solved for 0. Anyway, you get the idea. I think you got this. I'm going to go ahead and sign off for today. Once again, it has been a pleasure helping you out. You guys are amazing. I hope to get everything figured out in terms of all my beautiful handwriting. I hope it gets back to where it needs to be for you guys, and I wish you the very best. As always, thank you for all you do. Thank you for your support. Thank you for studying. People who study are by far the most awesome people in the world. That's just the way it is. So I wish you the very best. Good luck on your tests. See you later.